Today's topic in embedded system is classification of embedded systems. Embedded systems can be classified into two. The first major classification is it is classified based on the performance and functional requirements. Based on that, it is again subdivided into four categories: real-time based embedded systems, standalone embedded systems, network-based embedded system, mobile-based devices. The second major classification in embedded systems are based on the performance of the microcontrollers used in that particular embedded system. In this category, it is again classified into three. The first one is small scale embedded systems, next medium scale embedded systems, the third one is sophisticated embedded systems. The first major classification is based on the performance and functional requirements. In this, the first one is standalone embedded systems. In the standalone embedded systems, by the name itself, they can be worked themselves. They are self-sufficient and self-operated. They do not depend on any of the host system. In standalone embedded systems, they does not require a host system like a computer. It can work by itself. The various inputs can be received via the sensors, keypad or push buttons or any of the input ports, either by the analog or in the form of digital input. The collected inputs are getting processed and calculated and converted the data and giving the result data to the connected devices. The connected devices may be controls, drivers or displays. Standalone embedded systems are made in a way such that whenever the input is received, after that the input is getting processed, thereafter the desired output is produced. The examples of standalone embedded systems are MP3 players, digital cameras, video game consoles, microwave ovens, temperature measurement systems, etc. The second classification is real-time embedded systems. In the real-time embedded systems, the system should provide the output in a required time or in a specified time. Real-time embedded systems are designed and created to perform some specific work or function in a pre-specified time. In this type of embedded systems, it should follow the time deadlines to complete the task. There are two types of real-time embedded systems are available. They are soft real-time embedded systems and hard real-time embedded systems. In soft real-time embedded systems means it should be also follow the deadline, but some deviation in the deadline is acceptable one. But in a hard real-time embedded systems, it should follow the deadline strictly. If there is a deviation in the deadline means it is not acceptable. The third variety of networked embedded system is networked embedded systems or network-based embedded systems. These type of embedded systems are connected to a network to access the various resources. The connected network may be a LAN, WAN, or through it may be connected to the internet. The connection may be a wired one or a wireless one. This type of embedded system is the fastest growing area in embedded system applications. The embedded web server is a type of network-based embedded system where all the embedded devices are connected to the web server and accessed and also controlled by a web browser. The best example is LAN networked embedded system in a home security system in which all the sensors are connected and run on the protocol of TCP or IP. The fourth type is mobile-based embedded devices or mobile-based embedded systems. Mobile-based embedded systems are used in all the portable embedded devices like cell phones, mobile phones, digital cameras, MP3 players, and personal digital assistants. The basic limitation of this particular type of embedded system is limitations in the other resources and also in the memory. The second major classification is based on the performance of the microcontrollers. In this category, it is again subdivided into small scale embedded systems, medium scale embedded systems. Third one is sophisticated embedded systems. The first subdivision is small scale embedded systems. In the small scale embedded systems are suitable for simple applications. In this type of applications, the performance is not time critical. These embedded systems are normally made by the low performance as well as low cost 8-bit or 16-bit processors or controllers. They can be operated by a battery. The small scale embedded systems may contain the operating system or some of the embedded systems or may not contain any of the operating systems. For developing a embedded software for small scale embedded system, the main programming tools used are editor, assembler, cross assembler, and integrated development environment. The second category based on the performance of the microcontrollers are medium scale embedded systems. These type of embedded systems are slightly complex in the hardware and firmware compared to the small scale embedded systems. This type of embedded system may contain general purpose operating systems or it may be contain real-time operating systems. These embedded systems built around by using the low-cost 16-bit or 32-bit microprocessors or microcontrollers or RISC or DSPs. For developing embedded software for medium-scale embedded systems, the main programming tools used are C, C++, Java, Visual C++, real-time operating system debugger, source code engineering tool, simulators, and integrated design environment. Large-scale embedded systems. It may be also called as complex embedded systems or sophisticated embedded systems. This type of embedded systems have enormous hardware and software complexities compared to the medium-scale embedded systems. They may use application-specific instruction set processor, that is ASIC, intellectual property, that is IP. Actually, IP core is a block of logic or data that is used in making a field programmable gate array or application-specific integrated circuits. PLAs, programmable logic arrays, scalable or configurable processors. This type of embedded systems are using high performance microprocessors or microcontrollers with a bit of 32 or 64, and also RSOC, reconfigurable system on chip or multi-core processors, and as well as programmable logic devices. The systems may contain multiple processors or multiple controllers and also some core units or hardware accelerators to speed up the processing and also for offloading the processing requirements from the main processor. It should contain real-time operating systems for scheduling, prioritization and management of various processes and various tasks. The best example for the complex or sophisticated embedded system is edge cutting application. In this type of application, the hardware as well as the software co-design and components should be connected together or integrated together to provide a final system.